Hello everyone. Welcome to the Syed School. Today, we will learn about implementing OSPF. Before the configuration, let's take a look at the OSPF configuration commands. OSPF Process ID. An OSPF process ID is a unique identifier for an OSPF process on a router. It is used to distinguish between multiple OSPF processes that may be running on the same router. Multiple processes. A router can run multiple OSPF processes, each with its own process ID. This allows for different OSPF domains to be configured on the same router. Configuration. The process ID is configured using this command. Default process ID is 1. OSPF network command. In OSPF, the network command is crucial for defining the networks that a router will advertise to its OSPF neighbors. It essentially tells the router which networks it's directly connected to and should include in its routing table. Basic syntax is given below. What does wildcard mask do? Wildcard mask helps the OSPF process choose the router interfaces with different subnets and enables OSPF on that interfaces. Suppose router have interfaces with subnets 10.1.1.0/24. 2.0/24, 3.0/24. If I make the wildcard mask as 0.255.255.255 in the network command with network 10.0.0.0.0, then the router will enable OSPF on all the interfaces. 0 tells the router to consider the octet while choosing the subnets. 255 tells the router to ignore the octet while choosing the subnets. Consider the previous command. Only 10 is checked in this case. Let's take first router interface subnet. We have 10 in the first octet, so OSPF gets enabled on this interface. Second router interface subnet. 10 in first octet, OSPF gets enabled, similarly third subnet. Suppose we change the wildcard mask to 0.0.0.255. Then all three octets are considered. Let's consider this command. First three octets will get checked. So, OSPF will be enabled on just one interface with 10.1.2.0/24 subnet. We need to decide the wildcard mask based on the situation. In this case, if I need to enable OSPF on all the three interfaces, I will choose the mask as 0.255.255.255. If I need to enable just one interface, I will choose the mask as 0.0.0.255. Let's configure OSPF now. Consider this topology. We use 5 subnets here. 3 subnets for router-router link. 1 subnet for the switch VLAN as 3 routers are connected to the same VLAN. 1 subnet for router 1F1/0 port. We will assign IP address according to the subnets as .1, .2, and in the VLAN as .1, .2 and .3. I have already assigned IP addresses here. We will configure OSPF on these routers. Please remember the topology, IP addresses, and the subnets here. We have skipped subnet 5 here for simplicity. 10.1.5.1 IP address is not assigned to router 1. Let's configure OSPF in router 1. We have used the process command here. Now, comes the network command with just first octet 0 wildcard mask as I want to enable OSPF on all the interfaces with one command. All interfaces subnet first octet is 10 and so, all gets OSPF. Same commands on router 2, 3, and 4 to enable OSPF on all the interfaces. OSPF is as simple as that. Now, all the router will learn routes dynamically. Let's use some OSPF commands now to check the OSPF details. We use this command in user mode. We confirm routing protocol here. This is the router ID, which will be the highest IP address of all the interfaces on the router. On this router it is this as we have skipped subnet 5. We can change router ID 2 using a command. Now, this command in enable mode to check OSPF interfaces in detail. We see the network type as broadcast here, which we will learn later. Broadcast network type chooses DR and BDR even with two routers on a link. Now, this command to check the neighbor's details. We see neighbor router ID, its address, and if the neighbor is fully adjacent or just two-way neighbor. We see if the neighbor is DR or BDR and the local interfaces. After becoming neighbors, routers exchange databases. Here is the command to check LSDB. As this is a single area, all the routers have the same LSDB. This is LSA1, also called router LSA. We will study these in detail at CCNP level. This is network LSA, also known as LSA2. Now, this command to check if the routers learned routes dynamically. Here O is OSPF. We see that the router 1 learned the route to the subnet 410.1.4.0/24 dynamically using OSPF. Here 110 is the OSPF administrative distance and 2 is the cost. We have 2 more routes to the subnet 4. This is the command to check the OSPF interfaces in brief. We see interface number, IP address, process ID, area, cost, and the interface state. Let's change the router to router ID using these commands. Router ID needs to be in 4 octets. However, router asks us to reload or use a particular command so that the new router ID gets assigned. I am executing this command in enable mode. Let's check if the router ID is changed. We can confirm that it has changed. We will learn much about OSPF in the next chapter. Thanks for watching.